Assalamualaikum. My name is Muhammad Syahmi Iskandar bin Bazli. So today for the Advanced Communication Technology BNF 44503, I will present the project Design a single band microstrip patch antenna at 60 GHz mm wave for 5G application. So we go through the introduction. So for the introduction, in this project, a single band microstrip patch antenna for 5G radio application is present. The antenna is simulated by electromagnetic simulation and computer software technology for microwave study. The proposed single band antenna and the simulation result for return loss, VSWR, surface current and 3D radiation diagram are presented. The simulated antenna shows a return loss of 40.99 dB at 60 GHz. With advanced wireless technology, the rapid increase in the microband patch antenna requirement to introduce the high data transmission standard and low manufacturing cost is becoming the millimeter wave suitable for business purposes. The Federal Communication Commission has assigned the 5,964 bands as an unlicensed band, the frequency of which is acceptable for high-speed, short-range and short-range wireless communication. So they are assigned to a 60 GHz band with a larger bandwidth on a millimeter wave frequency monitors the LAN and WiGig standard IEEE 802.11 AD. This spectrum to produce as high as 7 gigabit per second data transfer rate and 60 GHz ISM band to execute the level of bandwidth required and minimize the interference volume. The WiGig standard enables the device to communicate wirelessly at multi-gigabit speeds and enable wireless high presentation display data and audio application. For the methodology, how we do the single band, mostly priority on the 60 GHz mm wave frequency, which will be used for future 5G application. With the concept of increasing the frequency data rate in a higher band, the data transmission area become smaller and a large bandwidth is required. In this single band, the antenna design shows a new H slot and E slot loaded in the patch. The design antenna used the 50 ohm microstrip line feed and are simulated by the CST software. The geometry of the proposed 60 GHz single band microstrip patch antenna is created. So a patch acts as an antenna for the main radiator element. The microstrip patch is delivered over the 50 ohm microstrip line. Then the antenna, as shown in the figure, has dimension of 8 mm times 8 mm at 60 GHz for wireless millimeter wave application. The antenna is simulated on a Rogers RT5880 dielectric. The substrate has a relative permittivity of 2.2, a loss tangent of 0.0009 and a height of 1.6 mm. CST microwave study EM simulation software is used for simulation purpose. Okay, we can see that the diagram show the measurement of each parameter is given for this project. Based on the table, the value is shown for the each length and width based on the diagram. So for the simulation result, this is simulated using commercial CST microwave software program. The simulated return loss reflection coefficient result for the single band antenna is shown in the figure below. The proposed single band antenna is negative 10 dB bandwidth of the microwave frequency and cover the 60 GHz millimeter wave frequency. This design outcome have center frequency at 59.93 GHz with bandwidth of 4.028 GHz reaching from 57.981 GHz to up to 62.009 GHz respectively. 57.981 GHz and 62.009 GHz respectively. Okay, figure below show the VSWR less than 2 at 60 GHz band, which represent the good impedance matching from proposed single band antenna. Then the surface current distribution of preferred antenna is present in the figure. At the edge of the patch and below the slot, larger amount of current flow, whereas almost uniformly current distributed in the other area for in this result. This for the radiation pattern of proposed antenna is shown. Then the figure below, proposed single band antenna has a gain of 5.48 dB with the radiation efficiency of negative 1.65, 1.549 dB at total efficiency of negative 2.423 dB at 60 GHz millimeter wave frequency. So this table comparison between the proposed antenna and reference antenna. So this proposed antenna show the smaller size, better return loss and better impedance bandwidth. So as a conclusion, a slot single band microstrip patch antenna for 5G radio application is presented. The proposed antenna is simple in structure, low in cost and small in size. The small size of the antenna drives the single band frequency and slot E improvement of the impedance bandwidth. The result of this design show the center frequency at 59.93 GHz with a bandwidth of 4.028 GHz in the range of 57.981 GHz and 62.009 GHz respectively. The proposed microstrip patch antenna have a gain of up to 5.42 dB for wireless millimeter wave application. So that's all. Thank you.